Well, we're going to review problem 1. It says that an object is moving in a straight line when time is 0. This is the velocity, 6 minus 2t. So we need to get displacement and distance. To get displacement, we grab the velocity that it gave us and antiderivated it to get the position. And it says that time is 0, so position is also 0. Now we can put the 0 in the t's to substitute and have c equal to 0. Then with this we can substitute the time 5 in the formula, so displacement is 5. To find the displacement is very easy. You only need to find the intervals from 0 to 5, the absolute value of the function of velocity. Now we need to factorize to find the x. Then we find the other intervals. That we can use this because it says that x is lower than 3, so we can use it because this is 0, this is more than 0 and less than 5, our 3, and this that is, we can use it because it's more than 5 and our limit is 5. Then we integrate them. Here the 2's cancel, and here b is 9, 0, so answer is 9. And here minus 5 and minus 9 equal 4. Now we only need to add these values and it's 13.
Hello, today we're going to solve this problem. So, the problem is giving us an acceleration formula, which is this one. And first, it is asking us for an expression that represents the particle's velocity. To get this, we have to integrate. We'll use this formula. This formula tells us that if we have a letter with an exponent, all we have to do is sum 1 to the exponent and divide it by the same number we got. So, knowing that, we know that the velocity will be the same as integrating the acceleration. So, we will get this by integrating. This we can simplify to this. Okay. Then the problem tells us that at time 0 the particle will have a velocity of 24. So we will substitute 24 as the velocity and the time as 0, and we get this. So c will be equal to 24. So now we know the expression for the velocity, which will be this. This is our letter A. Then it is asking us for another expression, but this time for the particle's position. So all we have to do is integrate this one. By integrating, we will get this, which we can simplify. Okay, then the problem tells us that at time 1, the position is 20. So we do the same as before. The position is 20 and the time will be 1. So we just solve for c. Now we know what's the expression for position.
Answer letter C, we need to find the total distance traveled from time equal 1 to time equals 3. This is the same as total displacement. We need to use the velocity formula we got before. We need to use it as an absolute value in order we can get the total displacement. The total displacement is the area beneath the curve of the velocity formula. So the second step is to get the zeros. In this case it will be 4 and 2. After that we need to establish ranges. Our integrate goes from 1 to 3 and our zeros are 2 and 4. So we'll have a range that is between 2 and 4 and a range that is less than 2. So we need to test these values. Between 2 and 4, that is 3. We substitute this in our formula. We're going to get minus 3. Less than 2, we will use 0. If we substitute this in the formula, we'll get 24. This tells us that this part of the graph we need to change the sign. Step number 4 is to integrate the function. After using our formula, we'll get this as an answer in a range from 1 to 3. So in step number 5, we need to take into account the ranges we established before and the range from the integral, and we'll have f3 and f2 and f2 and f1. Substitute these values in our function and we're going to get 18 plus c and 20 plus c, 20 plus c and 16 plus c. In this first case, where we have two values, we're going to subtract them, getting as an answer minus 2. But if you remember, we said that this range we needed to change the sign, so after changing the sign we get 2. We do the same thing here, we subtract and we get as an answer 4. And the last thing to do to add the two values, and we're going to get as an answer 6.